having a look here at applications of reciprocal functions. Now, as a quick recap, a reciprocal function is one where as one of the numbers grows larger, as one of our variables, x or y grows larger, the other grows smaller, and vice versa. Now, when we deal with reciprocal functions that just involve x and y, then we can have positive numbers and negative numbers for x and y. But when we're dealing with application questions, we're normally only dealing with positives. It's pretty rare that we would deal with something that involves negatives. So a reciprocal function is something like a speed, distance, time example. I have to travel 400 kilometers. If I travel at 100 kilometers an hour, it takes me 4 hours. If I travel at 50 kilometers an hour, it takes me 8 hours. The faster I travel, as one number goes up, the less time it takes me, the other number goes down. Okay, and vice versa. If I travel slower, it takes me longer to get there. But we're never going to deal with the negatives of those. Okay, if I want to buy something and I'm splitting it between three friends. Okay, let's say I'm buying an appliance. I'm buying a new fridge for my share house. And I'm going to split the cost with 3 friends. So there's 4 of us paying for it. We divide the cost of the fridge by 4. If just one friend's going to split it with me, then we divide the cost by 2. The greater number of people that share the cost, the less it costs each person. That's kind of like the example we're looking at here with Paul. He rents a guest house for $360 per week, and he's going to try to save some money by getting more people to get in on this. Now, a little bit of legal advice here. If you want to have people stay at your rental house, check with the landlord first to make sure that the landlord is okay with it. If you want to do something like Airbnb as well, again, check that your landlord is okay with that if you are renting, so that you don't get yourself any strife. You've also got to declare that money as income on a tax return as well. But those are just little side life application suggestions if you want to stay out of trouble. But let's have a look at our question here. We've got an equation, okay, a formula that models this. C equals 360 over n, where C is the cost each person pays and n is the number of people. Now, we don't have a 0 here, okay? We don't have a 0 in our table of values because there can't be nobody staying there. If there's nobody staying there, Paul still has to pay $360. If he goes on holiday for a week, he still has to pay $360 for his rent. He doesn't, it's not like a hotel where he says, well, I checked out for a week, so I don't have to pay. He still has to pay. So 1 in our table of values here means it's just Paul. Okay, Paul plus 1 friend would be 2 people, and so on. So we're going to complete our table of values here. So if it's just Paul staying, he's going to pay $360 for the week, which is just 360 over 1. If it's 2 people, it'll be 180. 360 over 3 is 120. Then we come down to 90. 360 over 5 be $72 per person, and 360 over 6 would be $60 per person. Okay, so you can see the more people that are staying, 6 people in the house, you're paying $60 per person, whereas if you've got just 2 of you in the house, it'd be $180 per person. Okay, 3 times as many people is 1/3 of the cost per person. Still the same amount of money going to the landlord, as long as they are okay with this, then as many people can stay as is practical. With any sort of question like this, you always got to be thinking, is there a practical limit to this? Now, you'd have to say, yes, there is, because assuming this is not some sort of grand manor, you couldn't have 200 people staying here. Okay, there would be a limit to saying how many beds or couches or spaces on the floor are there for people to stay. There would be a limit to this. Our second part is to graph this. Now, on our y-axis is going to be C, and on our x-axis is going to be N, because the cost per person is dependent on the number of people that are staying. So the independent variable is the number of people. So we plot our points here from our table of values. I've got 1, 360, 2, 180, 3, 120, 4, 90, 5, be about there, and then 660. We're going to go connect those, and we're going to have a curve here. Now I'm actually going to do something. I'm going to start it from that point there, and I'll explain why. I'm going to continue it along in this direction. but I'm actually going to fix it there and not have an arrow on the end. I'm going to be a little bit picky about this because the next part of the question talks about half values. What's like saying, is half a person staying there? Is that a child staying there? No, what that's saying is if Paul was going to split up and saying, well, if you stay half a week, then you only pay for half a week instead of a whole week being there. It's getting a little bit fiddly, but you couldn't have less than one person because it wasn't say, well, if I was to stay there for half a week, I had to pay had to pay $720. Not quite how it works. If Paul were to stay there for half a week and then go on holidays for half a week, or just not be there for half a week, he's still got to pay $360. Okay, he can't then say, well, I need to pay more to cover part of that. So we can have half values after one, but the smallest value you can have here is 1. But we can continue infinitely. We have talked about the practicalities of that. We're not going to go on forever and ever. We might be able to get 10 people in there paying $36 each, or 12 people in there paying $30 each. Might be a very tight squeeze, but it could still work. We're probably not going to get 200 people in there though. Having a look at some things we might do with this type of question, this type of graph here in our table of values. What is the cost when 3 people, including Paul, stay for the whole week? Well, we did this as part of our table of values. So when n equals 3, our cost was $120 per person. Okay, 2 people stay all week and 5 people stay for half a week. Use the graph to estimate the cost per person. Well, we could use the graph here, or we could go and use use our equation. So we know that C equals 360 over n. And what we need to do is work out our n value here. So our n value here is going to be, well, 2 wholes plus 5 halves. And again, this is assuming that Paul's willing to be very flexible here with his pricing structure. So I'm talking about Paul a lot because there's some practicalities to this here, which would be 4.5. The equivalent of 4.5 or 4.5 people staying all week. So if we said our cost now was going to be 360 over 4.5, our value for 4 was $90, and our value for 5 was $72. So it's somewhere in between there, which is $80 per person. Okay, and the last part here, explain how the cost could be $144. Well, we can actually go and split this, our number of people, sorry, rather than split, we'll say flip this and say n equals 360 over C. Now, the way we get there, by the way, is to say we know our cost per person times the number of people has to equal 360. So by dividing both sides there by C, I end up with my equation here. Now, if I know my C is going to be 144 per person, well, then I'd have to say N is 360 over 144, or 2.5 people. Now, that's not to say there's 2.5 people staying in the house, like 2 adults and 1 children or something like that. That's to say that there would maybe 2 people who stay all week and 1 person who stays half a week. Okay, or Paul who stays the whole week, and then 3 other people who stay half a week in some sort of rotation. Okay, so the equivalent of 2.5 people for a week, and there's lots of different ways you could get there. I hope this has been helpful.